Okay, welcome everyone at tonight's Build Tech Talk about blockchain. I'm your host for tonight. Let me introduce myself. My name is Maarten Splinter. I'm a test consultant at Capgemini since 1.5 years. Since 2017, when I discovered Ethereum, I became first interested in blockchain, following different kinds of projects. One of my favorite projects right now is Basic Attention Token. For people that don't know this, check out the Brave browser. I think it's one of the best browsers to have right now. What's most cool for me is to see how people, really get blockchain that don't have an understanding right away of it. So a few years ago, when I was driving my uncle, aunt, and nephew to the airport, I remember having this conversation with my skeptic uncle. He was very skeptic about blockchain, and he said to me, "Oh, Maarten, blockchain, that's dangerous. It's a pyramid scheme, etc." So I already read about the technology. I knew about smart contracts. I knew how to do transactions. So I talked to my uncle in the car and told him a little bit about blockchain. And when we arrived at the airport, he told me that he would look into it and check it out. So he became a little bit more open-minded. And 2 weeks later, when he returned from his holiday, I had to come by and set up a Coinbase account and a Binance account. And I showed him how to do transactions. And it's really cool because nowadays he knows about more projects than I do, and he's still reading up on all these blockchain things online. So that's really cool for me to see how some people become really skeptic and then they totally change their view of blockchain when they understand it. So hopefully tonight we also have some lay persons in the audience, and hopefully we'll be able to transfer some knowledge to these people regarding blockchain. So for tonight's program, we have two presentations given by two of Capgemini's consultants. Our first presentation will be given by Derin Karim. He will explain the technology and give a basic understanding about blockchain. Afterwards, Menno Bruijn will give a second presentation regarding a cool blockchain use case about in-game items. After each presentation, we'll have time for Q&A, so please drop your questions in the comment section. That's it from me. So first up is Derin Karim. He will introduce himself in a moment.
Yes,
Derin,
thank
welcome.
you. Hey, Maarten, how are you doing?
Very, very fine. First of all, Derin, let me ask you, when did you actually become interested in blockchain technology?
So I was really interested in blockchain in late 2016. But the fun thing is, I was also like that same kind of guy as your skeptical uncle.
Really?
So in 2012, I was as a trainee at this company, and one of my colleagues who worked over there, an IT guy, he talked about blockchain, particularly Bitcoin, and he owned some Bitcoins. He told everybody how it worked, and I was that guy who said, "Dude, that's the biggest scam out there. That's a pyramid scheme, right?" And it's so funny. So yeah, I see your skeptical uncle also in me. But a few years, So a few years later, my little brother told me, "Yo, you need to look into this thing. It's called Bitcoin." And I said, "No, listen, I've heard about it. I'm not going to look into it." So he put a bit of his money into it, and then I was like, let's dive into a bit and let's dive into this technology and see how it works. And I was sold. I was sold. Like, when you understand it, it's just crazy. But it's a huge learning curve. So that's the main barrier where people struggle with.
Exactly. Okay, cool, Derin. Thank you. Ladies and gentlemen, without further ado, allow me to give the stage to Derin. Derin, please teach us about blockchain.
Thank you, Maarten. Thank you. So welcome, everybody. Thank you for your participation. I'm excited to share my knowledge and insights about blockchain. Blockchain is not an easy subject and is also difficult for many to follow. On a daily basis, I'm involved with the development, not the technical developments, but the business side of things. And it's also, especially with the monetary aspect, And it's taken years to understand its politics, the monetary policy, privacy, security, and the possibilities of it. So I'm still learning every day. I'm going to show you at a high level and explain what blockchain is and how it works under the hood. Keep in mind that some of the visualizations are simplified to make it more sensible and understandable. My colleague Menno will explain the technical side of things of the blockchain, and he will dive into the code with you guys. So without further ado, let's dive into it. So where am I? I'm Derin Karim, 28 years old. I'm an IT consultant at Capgemini. I was born in Kurdistan. I studied business IT and management. I worked in the IT branch since 2012 for various roles, the business development and project director of various blockchain projects. And particularly one of them was like a decentralized cloud environment. You can compare it with a decentralized AWS. So I've always had this passion for technology when it comes to tech and blockchain or AI or machine learning, whatever it is. So I love keeping shape and play soccer. Also, I love reading about monetary economics, monetary history, and I'm an investor myself. So that's me in a nutshell, and let's see what the program of tonight is all about. So I will talk about what blockchain is. So in my examples, I will mainly talk about the Bitcoin blockchain technology. We are going to talk about how it works and show you some use cases of some blockchain technology. So I always say the potential is comparable actually with the internet. The internet made information openly accessible, and people from all over the world can communicate with each other, right? So the internet is a revolution in access to information. Blockchain is a revolution in trust. With blockchain, you can make transactions possible between people who don't know each other or nor they trust each other, without the need actually for a central party or a intermediary or a middleman. So this technology is so actually powerful that it can transform the very basic pillars of our society. A technology which is actually fundamentally influences the way that our economy, governance systems, and business functions, and change our conceptual understanding of trade, ownership, and trust. So what is a blockchain actually? A blockchain is often compared to a ledger. So as you guys might know, a ledger is an accounting concept and contains all of the income and expenses of a company. You can think of a blockchain as a digital ledger in which transactions are recorded. This ledger contains all the transactions that have ever been made. All kinds of transactions can be recorded in the general ledger. In one case, it's a payment with like a digital currency, like the Bitcoin, or in the other case, to exchange important data between two parties, such as contracts, certificates, or titles of ownerships. They have one thing in common, though. They become blocks of information that are digitally signed by both parties, but without the intervention of a third party. So people think of Bitcoin as only a virtual money or transaction system, but if you really look closer, you will see that the monetary aspect is just a tip of the iceberg. That's because Bitcoin is a groundbreaking internet technology from my point of view, for which money is merely one of the possible applications. So money exists to trade, to facilitate trade, right? Trade has become complex over the centuries. Everybody trades with everybody, and that is all being recorded in bookkeepings. So this information is often isolated and close to the public. For this reason, we can use third parties and middlemen to trust to facilitate and prove our transactions. So think about governments, banks, accountants, notaries, and the paper in your paper money in your wallets. We also call this trusted third parties. And this brings us to the essence of blockchain technology. So the blockchain enables a network of computers to keep joint accounts via the internet. These accounts are not privately or owned by one party, but are contained in one public digital ledger that is fully distributed over the whole network. The blockchain contains all the transactions with associate dates, times, and also their owners, also including their balances. So every node in the network owns a full copy of the blockchain. So you can think of it as a large digital public ledger. So every transaction is public, and many thousands of nodes agree that the transaction has taken place undisputed. You can think of it, it's like a notary between every transaction to stamp and verify the transaction. So here we have an overview about the centralized and decentralized and the distributed overview. So as we know, most databases and ledgers are centrally organized. That means that there is one location where all the data is stored. Only in that place, the data will be added, changed, or deleted. So there might be a single point of failure. But blockchains come into their own when organized differently, like centralized, decentralized, or distributed. There is no central point there's no central point actually, but there are several nodes that are contained as a copy of the database or general ledger. So all those nodes together, we call it the blockchain network. So these nodes perform work for the network itself. So think of listening to the new transaction and collecting them into one block, calculate the correct signature for the block, or make the block known to the network, so broadcasting the blockchains to the nodes. So in fact, the fact that the blockchain is distributed across multiple nodes makes it even less susceptible to fraud. So we all looked into that in just a bit. But what is a blockchain, right? So how do they work? What problems do they solve? And how can they be used? Like the name already indicates, the blockchain is a chain of blocks that contains information. So this technique was originally described in 1991 by a group of researchers and was originally intended to timestamp digital documents, so that's not possible to backdate them or to tamper with them. You can think of it as a notary. However, it went by mostly unused until it was adapted by Satoshi Nakamoto in 2009 to create the digital cryptocurrency called Bitcoin. And I think most of you guys are familiar with the Bitcoin who's watching this. So his goal was to create a monetary asset which wasn't controlled by any government. And its philosophy was based on libertarian Austrian economics. So one of the famous quotes you see over here is like, with e-currency based on cryptographic proof, without the need to trust a third-party middleman, money can be secure and transactions effortless. So it's a total new mindset and digital asset which came into existence. So let's see how blockchain works. So a blockchain is what we already mentioned, a distributed ledger that's completely open to anyone. They have an interesting property though. Once some data has been recorded inside a blockchain, it becomes very, very difficult to change it. So how does that work? Well, let's see. So each block contains some data, the hash, and the hash of the previous block. Let's zoom into the data. The data that is stored inside a block depends on the type of blockchain. The Bitcoin blockchain, for example, stores the details about the transaction in here, like such as the sender, the receiver, and the amount of coins which is sent. That's very basic overview about the Bitcoin blockchain. A block has also a hash, which we said. So you can compare it as a fingerprint. It identifies a block and all of this contents, and it's always unique, just like a fingerprint. Once a block is created, its hash is being calculated. Changing something inside the block will cause the hash to change as well. So in other words, hashes are very useful when it comes to detecting changes to the block. If the fingerprints of the block changes, it's no longer the same block. And the last element is each block has a hash of the previous block. So this effectively creates a chain of blocks, and it's unique that makes this blockchain so secure. Let's go into example. Here we have a chain of 3 blocks. As you can see, each block has a hash of the previous block. So number 3 points to the number 2, and number 2 points to number 1. Now, the first block is a bit special. Pointing to the previous block, because it's the first one, it's not possible. So we call it the Genesis block. That is broadcasted openly into the network. I'm not going to dive into the Genesis block, but it's openly and it's not relevant to the hashing of previous blocks. Now let's say that you tamper with the second block, right? This causes the hash of the block to change as well. In turn, that will make block 3 and the following blocks invalid because they are no longer store the valid hash of the previous block. So changing a single block will make the following blocks invalid. But using hashes is not actually enough to tampering, to prevent actually tampering. Computers these days are very fast, as you guys know, and can calculate hundreds of thousands of hashes per second. You can effectively tamper with a block and recalculate all the hashes of the other blocks to make your block valid again. So to mitigate this, blockchains have something called proof of work. It's a mechanism that slows down the creation of new blocks. In Bitcoin's case, it takes around 10 minutes to calculate the required proof of work and add a new block to the chain. This mechanism is very hard to tamper with. And because if you tamper with one block, you need to recalculate the proof of work for all the following blocks. So the security of a blockchain comes from its creative use of hashing and the proof of work mechanism. But there's one more way that blockchain secures themselves, and that's by being distributed, what we talked about already. Instead of using central identity to manage the chain, blockchain use a peer-to-peer network, and actually anyone in the network is allowed to join. So when someone joins this network, he gets the full copy of the blockchain. The node can use this to verify that everything is still in order. Now, let's see what happens when someone creates a new block. That block is sent to everyone on the network. Each node then verifies the block to make sure that it hasn't been tampered with. And if everything checks out, every node adds this block to their own blockchain. So all the nodes in this network creates consensus. They agree about what blocks are valid and which aren't. So blocks are tampered with will be rejected by other nodes in a network. So to successfully tamper with the blockchain, you will need to tamper with the blockchain itself, redo the proof of stake for each block, and take control even also for more than 50% of the peer-to-peer network. Only then will your tampered block become accepted by everyone else. It's actually impossible to do so. So in the past slides, you have seen the most important aspect of a blockchain. So mainly the Bitcoin blockchain, but there are also several generations of blockchain. For example, we talked about the Bitcoin as the first generation. Ethereum, as you guys know, is a second generation. And IOTA, Neo can be said as a third generation. So, and the fourth generation is now under development. Think about oracles like Chainlink. So blockchains are constantly evolving as well. One of the more recent developments is the creation of smart contracts. So this came into existence when in 2016 the Ethereum blockchain came actually in a market or public to anyone. So these contracts, these smart contracts, are simple programs that are stored on the blockchain and can be used automatically to exchange coins based on certain conditions. So Menno will zoom more into the details of smart contract in just a bit, but the possibilities are very, very promising. But let's look beyond cryptocurrencies. Let's see what kind of use cases these kind of blockchains are useful for. As shown here, there are many use cases for blockchain technology. Think about money we talked about. We will talk about something about real estate and healthcare. Some of them are a no-brainer, like supply chain, and already used by some of the companies, while some of them are still under development and close to a real-life use case. Now, let's look how blockchain technology can be used by cars, for example. You probably ever heard of the odometer fraud, right? So by tampering with the odometer, someone can make a car appear to be newer and less worn out, resulting in customers paying more than what the car is actually worth. The government tries to counter this by collecting the mileage of the car when they get a safety inspection, but actually that isn't enough. So instead, we could replace regular odometers with smart ones that are connected to the internet and frequently write the car's mileage to the blockchain. So this will create a secure digital certificate for each car. And because we use blockchain, no one can tamper with the data and everyone can look up the vehicle's history. In fact, this is already being used and developed by Bosch IoT Lab, and they are currently testing on a fleet of 100 cars in Germany and Switzerland. So we know that blockchains are great at keeping track of things over time, but besides odometers, you can also track of things like intellectual property, patents, and even functions like a notary. Let's zoom in about that. See, a notary is someone who can confirm and verify signatures on the legal documents, but we can just as well use the blockchain for it. The online website stamp.io, for instance, allows you and me to add documents to the Bitcoin or Ethereum blockchain. So once added, you can always prove that you created a document at a certain point in time, much like a notary. Although right now blockchains aren't on the same level as a notary in a legal perspective. So another interesting application is digital voting. Right now, voting, as you guys know, appears either on paper or special computers that are running proprietary software. Voting on paper costs a lot of money, and electronic voting has some security issues as well. So in the recent years, there have been countries move away from the digital voting and adopting paper again because they fear that electronic votes can be tampered with and influenced by hackers. But instead of paper, we can use also the blockchain to cast and store votes. Such a system will be very transparent, as everyone could verify the voting count for themselves, and it will make tampering with the blockchain very, very difficult. So the Swiss company Agora, I think, Agora is already working on such a system and is going to be completely open source. But there are many challenges, to be honest. So first, you have to be able to identify voters without compromising their privacy. Secondly, if you are allowing people to vote with their own computers or phone, you have to take into account that those might be infected with malware designed to tamper with the voting process. So definitely an interesting use case of voting on a blockchain, but it becomes reality. But when it becomes reality for a more transparent and practical voting system, that will be very interesting as well. I think Donald Trump will be a very mad as well. So we don't get the situation about the election of last November. So let's move to yet another example, the food industry. They could use blockchain technology to track their food products from the moment they are harvested or made to where they end up with, like in the hands of customers. See, every year, almost 500,000 people die because of foodborne disease. And that's particularly because it takes too long to isolate the food that is causing harm. So blockchains could help us to create a digital certificate for each piece of food, providing where it came from and where it has been. So if a contamination is detected, we can track and trace it back to the roots and instantly notify other people who bought the same bad food. Walmart and IBM are currently working on such a system. It allows them to trace the origin of a box of mangoes in 2 seconds. Now, just compared to days or weeks in a traditional system. That's actually mind-blowing. A system like this could also be applied to other industries as well. We could use it to track regular products and battle counterfeit goods by allowing anyone to verify whenever a product comes from a manufacturer they think it does. Think about high quality or luxury brands, which are very counterfeit goods, which is used in third countries. So another idea would be to track packages and shipments by using blockchain. That is something that IBM and container ships giant Maersk are already working on. So a decentralized ledger to help with making global trades of goods very efficient. So far, actually, we looked at ways how blockchain can be used to track information and verify its integrity. But blockchain can be even more powerful when we add smart contracts into them, that we already talked about. So these smart contracts are tiny computers that live on the blockchain and can perform actions whenever like certain conditions are met. So insurance companies could use smart contracts to validate claims and calculate a payout. Or they can allow us to pay for car insurance when we are driving. But it goes even further. So with smart contracts, we can secure our own data on the blockchain, which is very important. They could, for instance, allow us to store our medical records on the blockchain and only allow the doctors to access them when we approve it with a digital signature. In the same fashion, you could store your personal identity on there and choose what data do you want to reveal. So think about ordering alcohol in a bar, for instance, only that requires you to prove that you are over the legal drinking age, and with a smart contract, you can deliver that proof without revealing actually anything else. So as you can see, blockchain technology can be used in very different ways. This is just a brief overview on how they could be used, and by no means a complete list of all the applications. Every day, developers are working hard on various innovative technologies and applications on the blockchains. Some will fail, and some already have partnerships with major enterprises. So myself, I'm very confident that it won't take very long. We actually see some of these use cases in mass adoption, like the voting system. I'm very a big fan of it. My colleague Menno will go deeper into the topic of smart contract with you guys in a fun and interesting way, where he's already working on in real life. So thank you for your attention, and I hope you have been able to make the subject blockchain more accessible at a higher level.
Okay. Derin, thank you for your presentation.
Thank you.
I can see we have 2 recent questions from our audience, both from Erik Stur. Let me start with this first question. Sometime one hears, perhaps unfounded, news about criminals having better possibilities to launder money using blockchain because it's more difficult to follow the money. What do you think?
Actually, I don't fully agree with that, but because on the blockchain you can really follow the money. The hard thing is to associate a certain address with a real life person. So you really can see, and it's transparent, the blockchain, where the money is and where it's going. So following the money is quite easy. It's preventing the money to be spending. That's the hard part.
Exactly. And if I would be a criminal, I probably would use a blockchain like Monero or something like that.
Absolutely, like privacy coins, right?
Exactly. Okay, another cool question. Could blockchain technology also be used in chains of news to verify that news is not tampered with, for example, and to perhaps enable proper validation of the first legitimate source?
Absolutely. I know, man, I forgot the name of this project, but they are already working on such a system, because it's this fake news or deep fake thing or whatever it is. It's a huge thing, a huge issue. huge issue in the America. So they're already working on it. And yes, Eric, they really can work on such a system to prevent that.
Okay, there's another question popping in right now. In a mining process, there is said to be a process in which mathematical problems are being solved. Which is the difficulty? Which the difficulty increases over time. What kind of problems are actually being solved here? It's a very technical question, Derin.
So they need to solve like a puzzle, a very hard mathematical puzzle, which is getting harder and harder if the hash rate increases. And yeah, it's very hard to explain the mining process actually, but it comes up to like there's a mathematical puzzle which you need computing power for it to solve it, and it's a really random generated puzzle. So I hope that answered your question. Else you might want to look up at the mining process of blockchain technology, which explains a lot.
Okay. Also, let's discuss the final question of Johan. Looking into the economics of Bitcoin, is it theoretically possible for anyone to increase the total supply of 21 million Bitcoin? If yes, how?
They could. So what I said is open source. It's open to anyone. So they could increase the supply rate of 21 million. But here's the thing. No one, like all the nodes, they won't agree that that's the proper Bitcoin core version. So you can copy the Bitcoin blockchain, but you don't have any nodes to validate your blockchain. So you don't participate with the 21 million version. Maybe you want to look up Bitcoin Cash, which already did some similar thing with the block size.
Okay, then a final question from me, Derin. Let's talk about money. That's always fun, I guess. What do you think the Bitcoin price will be by the end of this year, or let's say by the end of 21?
So first of all, I'm not a financial advisor, so I don't give any financial advice. So I'm a big believer in digital scarcity, especially when it comes to the Bitcoin application and the monetary policy. Again, it's just a thought. So don't invest your money in something which might be worth nothing. So I think it can be worth at least 100K by the end of 2021.
Okay, interesting.
Yeah, it's very interesting. Yeah, okay, I'm still in the game, so yeah.
I want to thank you for your presentation. Yeah, and we're going to continue with our program.
Thank you, Martin.
Thank you.
It was a pleasure. Thank you.
Okay, good night. Okay, let's continue with the program. Next up is Menno Bruijn with a presentation about in-game items. So for all your gamers out there, and especially gaming developers, this is an interesting topic. First, let me welcome Menno to the stage.
Hello.
Hi, Menno. Welcome. I remember myself in 2017, and I was astonished about this trend called crypto kitties. For the people that don't know crypto kitties, they are actual digital collectibles. Yeah, digital kitties. And much like as I like kitties in real life, I had no incentive to actually own a digital kitty myself. And I remember there was a time on the Ethereum blockchain when it got so clogged up by this trend because of the increase in transactions due to this new craze. And what most surprised me was the fact that people would actually pay money for these digital kitties. So Menno is going to talk tonight to us about digital items. And I just had to reminisce about crypto kitties. So let me ask Menno. Menno, you probably also know about this craze. What do you think the maximum price was that was paid for a crypto kitty back in, I think it was December 2017?
Well, I haven't looked at the maximum price of crypto kitties, but I think I remember I've seen some crypto kitties go for like 21,000 Ethereum, And that was because I went to the website of CryptoKitties to see what they look like, and well, the most expensive ones didn't look anything else than the more cheaper ones. But I don't recall what the maximum or what the price of Ethereum was at that point. I think it might have been like $50 or something. So I'm going for like $100,000 for CryptoKitty. I'm not sure if I'm even close.
It's well, pretty close though. It was $170,000.
Yeah, it's crazy. It's crazy. Well, we'll see more crazy examples of in-game item prices in my presentation.
Yeah. So let's start with your presentation. The floor is yours.
Thank you. Well, first, I would like to go back a little bit to the question of Johan, because I think I can answer his question about what mathematical problems will be solved and how the difficulty increases. It's actually a pretty simple concept, because the mathematical problem that is being solved is a SHA-256 hash problem, and well, I won't go in any specifics of what the inputs are, but the SHA hashing problem gives or takes any input that can be a word or it can be a sequence of numbers, and it returns a sequence of numbers of a specific length. So if you put in 10 numbers, you'll get 100 in return, but if you put in 200 numbers, then you'll get 100 in return as well. And the blockchain, or at least the Bitcoin algorithm, looks for a specific amount of zeros at the end. So if the difficulty is 5 zeros at the end, the computer starts calculating this maximum or this hash, and looks for a solution that has 5 zeros at the end. And if you want to increase the difficulty, you decrease the amount of zeros that you look for in the end, or you increase the amount of zeros that you look for in the end, because that will make a harder to find number. So that is what kind of calculation is being done to find the right solution to a block, and also explains how they can increase the difficulty or decrease the difficulty if they want to make it easier for computers to find the blocks. But well, that was the answer to that question, and I will now continue with my presentation about making in-game items real with blockchain. First, I would like to introduce myself. I'm Menno Bruijn, and I'm a test consultant at Capgemini. I've been involved with blockchain since, well, it says 2017 here, but it's actually 2014, because that's when I bought Bitcoin for the first time. But I actually sold it again to get a motorcycle. So I entered back in at around 2017, and then really started learning about blockchain. There's also a QR code over here. It's for a survey I made on Google Docs. It's about the price of in-game items. I think there will also be a link in the presentation, which you can click to go to the to this survey. Don't fill it in yet, because I will explain what it's all about a little later on. First, a bit more about myself. I've been a gamer for a long time now. I've played some of these games. You see in the top left, you see Counter-Strike Source. I've played that a lot. I've also played the game on the top right, which was called Road Rash, where you had to drive a motorcycle as fast as possible, but you could also kick the opponents off their motorcycle or use different weapons, like the chain this guy is using over here. And then I also played Age of Empires in the bottom right, which was a strategy game I used to play on a local area network with my father and my brother, and actually the neighbor kid was also involved. It was a lot of fun. Then afterwards, I started playing more role-playing games like World of Warcraft and Guild Wars 2, and that's actually where I really started seeing more the beauty of collecting special items, and the survey behind the QR code and the link, if you go there, will be about these in-game items and my presentation as well. So the question is, what is the price of these items? I'll go through them and then you can make your estimation. The top left one is the blue party hat. It's actually an item in RuneScape, and it was actually a limited edition item that was released for free to all the players right at the start of RuneScape. I think it was in 2004, or it's a really old item, and it was released to the public during a Christmas event. And well, you should guess the price of the item. Then below that, you see the nest egg. It's actually an item in Astoria. It's a game a bit like Second Life, but this item, it doesn't do anything. It doesn't provide any benefits for the owner. The only thing is that if a certain time passed in the game, I think it was a few months, then after that there was a special event that happened in the game. So I guess owning this item gave you the right to say that you were the person that caused that event in the game. But then again, my question for you is, what is the price of this item? Then the third one, the top right one, is a skin for a gun in Counter-Strike. It's actually not Counter-Strike Source, which I used to play, but a follow-up version. It's Counter-Strike Global Offensive. And this AWP skin, it's actually one of the most powerful guns in the game. And the skin was given out during one of the competitions that was being held for this game. And well, again, try to guess the worth, the amount of money this item was traded for. Then the last one, the bottom right one, it's actually a whole planet in the same game as the nest egg, Entropia, that was being sold. Well, I'll help you a little bit. It was not bought by a single player, but it was actually bought by a company. And I guess that company wanted to be the owner of a whole planet in this game, Entropia. So take your guess of what you think this item is worth. I'll get back to the answers a bit later on, because there's a small delay of 20 seconds between what's happening for me now and when you see this presentation. So I'll get back to the answers when all the answers are gathered. For now, I'll continue. Well, why are in-game items, or why is gaming growing so fast? Well, there's a lot of free-to-play games that are available for people, and things like a mobile phone, or the popularity of, for example, the PlayStation 5 is a great platform for game designers to make games more popular. And there's a lot of free-to-play games that are being created nowadays. I'll get back to some of these free-to-play games in a bit, but due to the popularity of these free-to-play games, the only way for the makers of these free-to-play games to make money is to create in-game items and sell them for real money. And well, that is why the in-game item market has also grown a lot. Well, I already talked about the PlayStation 5, and well, I don't know if any of you heard about it, but the popularity of the PlayStation 5 was immense. I think in the Netherlands there were like 200,000 orders, and Coolblue only had about 200 to 300, or even less than 200 to distribute among these orders after the PlayStation 5 released, and I think they still haven't caught up with the orders, even though it's been a few weeks now since the PlayStation 5 released. So the gaming is really popular right now. Then a few of these games, the free-to-play games I mentioned earlier. One of the biggest right now is Call of Duty Warzone. And one of the in-game items I would like to highlight here is you see this guy holding a golden weapon, and that's one of the skins for a weapon you can unlock when you reach a certain stage or when you get to a certain level with your weapon. Then here's Fortnite. I think that was one of the most popular games last year or a while back. One of the techniques these game makers use to get people more in-game items is battle passes. Right here you see the battle pass system for Fortnite, and using battle passes you can link leveling up to getting more items. And if people don't have a battle pass, they won't get the items when they level up. So you have an incentive to buy the battle pass and get more in-game items. Then following up with that, you see Apex Legends over here on the top right. This player over here has a special skin for his character. You see she has a certain look, a certain outfit, and usually these outfits are also being made to purchase to make your character look more special and make it unique. And lastly, here's the Elder Scrolls Online, and another way to motivate people to buy in-game items is what they did in Elder Scrolls Online was using loot boxes. And using loot boxes, you buy a box and you don't know what's in it, but you hope there's good items in there. And when you don't get good items, you want to buy another. But when you do get good items, it's a lot more random with loot boxes, and there's also been some problems with that, and maybe we'll touch on it later. But going back to the questionnaire, I hope you've all had the possibility to fill in the questionnaire. I'll go to my phone for a bit to check the answers. Well, there's some nice responses. For the blue party hat, the most popular response was 250 euros. But the item was worth a lot more, a tenfold of that. The last time a blue party hat was traded, it was traded for $2,500 to another person. So I guess this sets the trend for the other items. Going on to the Nasdaq. The answers are actually equally spaced, but the most popular answer was $10,000. I already showed it for a short moment, but it's actually 7 times that. It's not 10,000. It was 70,000 for an item that actually doesn't do anything for you, but you can only say, "I released an event on this game." Well, then the op skin for the for Counter-Strike. I see a lot of people overpricing this one. A lot of people actually guessed $147,000. It's actually a little cheaper. I think it's $63,000. And then for the last one, people went actually crazy for this one. Most of them answered 14 million, but it was a little less, but it's still very excessive. It was a 5 million for the planet Calypso. You get the point that these things can get really, really crazy. So it brings me to my next question. How do you put in-game items on a blockchain? Well, Derin already spoke about it. There's a possibility to use smart contracts on the Ethereum blockchain, and for the most part, I will stick to these smart contracts. Well, we already heard smart contracts are small pieces of code that are on the blockchain that can be triggered when certain conditions are met. And one of the things we need to put in-game tokens or items on a blockchain is tokenization. So that is a way to for a third party, like a company, to put items that or things they have digitized. They could be tickets, they could be records, or they could be in-game knives or swords in a certain game, and put them on a blockchain. And you could use a smart contract to do that, and I'll show you how you could do that on using a smart contract. Then you need non-fungible tokens. For a while, we talked about the use case of money for on a blockchain, but if you have €1 or $1 and you have it, then you have 2 times 50 cents, and it is still money. Those are fungible tokens, but non-fungible tokens are not divisible, and so if you have like 1 sword, you can't divide it into 2 swords because that just doesn't work. Non-fungible tokens are the same way. They are a different type of token that can't be divided. And then lastly, we need token standards. A token standard is actually a way to make sure everyone interprets a token in the same way. So if one person thinks of a way to create a token, it can be used on certain different platforms, and a token standard makes sure that it is interpreted. Well, for learning how to create tokens on a blockchain, I used Crypto Zombies. The website for that is www.cryptozombies.io. It's actually a coding course which learns you how to create a set of smart contracts that actually tokenizes these zombies you see on the right. And for my example, I actually adapted some of the code to recreate a sort of Hearthstone-like game on a blockchain. And it uses, instead of the zombies, it creates certain cards or trading cards, and it allows you to create decks of cards. It's similar to the way Crypto Zombies does it, but adds some other things to it. Well, to tokenize something, you actually need these 3 parts. First, a way to produce the token. Then ownership, and lastly, of course, the token standard to make sure that other platforms can also interpret your token the way you want it to. So going further, a piece of code I wrote based on the course I followed at cryptozombies.io. This is actually a smart contract. And a few things I want to highlight is the DNA digits and the DNA modulus. By tokenizing an item uses a hash for creating a unique set of numbers, which in turn can be converted into a token. And how that is done is this smart contract maps all the addresses that created tokens in this smart contract. So for instance, if I want to create a token in this smart contract, I will have to use one of the functions in this smart contract. And once I use this this function, my address is added to this list. It's actually a simple table which maps my address to the token that I created using one of these functions. And one of these functions is, for example, this create a card function. And what it does is it adds my my address to this smart contract, and then adds a card or a unique sequence of numbers to my address to show that I now own that sequence of numbers. If you look over here, this sequence of numbers, this hash, is being generated using some randomness. The way I did it over here is actually not possible anymore because I used the time to create not randomness, and time can be influenced by computers. So you have to do it in a different way right now. But when you get this random set of numbers and you map it to a person, so that person is now the owner of a random set of numbers, you then have to interpret that set of numbers. And crypto zombies actually does it in a certain in a very funny way. It takes the random hash. It takes the last 10 digits of that hash. It's, for example, it's this set of numbers, and then it applies certain interpretation characteristics. For example, the whole number determines the rarity. You can say that if a number like this starts with a 9 or with a 99, it is a lot rarer, and it shows certain characteristics, and if not, it doesn't. You can also use a certain set of numbers of this random hash to determine the color or the power. For example, in these cards, these both have the level of 7, and you can use this to interpret this random set of numbers that you mapped to an address. Going further, I also talked about the ownership of the cards. I already talked about mapping the set of numbers to an address, but you should also limit the actions that people can do with these cards that are now tokenized, and with this modifier, you can limit the actions that someone can do with these tokens, that only the owner of a token can do certain actions. And also, there's you see in the bottom of this function, you see an emit. That's actually when events happen on a blockchain, you want to get a certain notification of that to know what happened. And to look at that more closely, here's the token standard. It's actually ERC-721, which is a very common token standard in Ethereum. And there's also some events that happen that are being emitted once a token is used in a certain way. You can catch these events, and based on these events, you can interpret these in a program or in a game. Well, this is a lot of code, but what does this look like with the front end? So actually, I asked a student of the Hogeschool Utrecht earlier this year to create a proof of concept for a game that uses non-fungible tokens for items, and what was possible for that. So it looked the prototype he made looked a bit different, but I'll use this example. You log into a game using your wallet ID. You link your game to a wallet, and then you're playing the game. And for example, you kill some enemy and you find an item. And once you pick up that item, you instantly get that item in your wallet. To the left, you see the wallet, and you see the second item is the criminal's katana, and to the right you see this criminal's katana. This item, the criminal's katana, is generated based on the way the game interprets the random hash that is generated when this token is generated. On the bottom of the criminal's katana, I don't know if you can see it, you see a total supply. The total supply for this item is 23,857. Well, if this is a very popular game with 100,000 or 1 million players, this item could be pretty rare. There's only 24,000 items for the whole player base, which means not everyone can get this item. Then the program the student used to create the proof of concept was actually the engine platform, which makes it very easy to generate in-game items and to generate currency. So this is a look at the back end of the system. There's some in-game currency, some items that are fungible, but then there's also some non-fungible tokens on the second row. And to generate or to create these items on the back end, a developer can easily select whether they can be fungible or non-fungible, or the maximum supply is limited or unlimited, or if the items can be destroyed or can't be destroyed. That way they can control rarity or not. Well, the engine platform also made it very easy to trade items, in-game items that are being used in a game. So, for instance, this is the marketplace for the for items using the engine tokens, and you see the value of the items, and you see whether or not they are fungible tokens or non-fungible tokens. Well, why would a gaming company use a blockchain? Well, there's certain factors that are very very useful to, or there are certain situations where it's very useful to use a blockchain. For instance, when there's trust involved, or when you need to trust another person online that you don't know, which you have never met. And these situations, they happen a lot in games where you have a certain very rare item and you want to trade it with another person. You have to trust that they are honest and they don't scam you, or they don't go off with your item while not paying you, especially when you want to trade it for real money or for Bitcoin, for example. So the student I used to, or the student that created the proof of concept, actually dove into marketplaces that are currently available for in-game items. And some of these in-game items, you already saw in the start of this presentation, can be of ridiculous value. And in these marketplaces, the amount of hassle or the complications that you have to go through to trade an item from person to person are actually really really strange. Sometimes you have to take a video of your screen, or you have to validate your identity first, and then you have to trade it to a third party. And there's a lot of hassle trading. So trust is a big issue in games, especially when you don't know the other person you're trading with. Well, we already touched upon it. If there's more money involved, then there's more risk. So you need a secure way to trade items from person to person. Then there's the question of leftovers. There's a lot of games that ask you to deposit money to get in-game tokens. For example, the Call of Duty Warzone example I used earlier. You have to pay real money to get in-game tokens, the COD points, and well, the first item or the first thing you can buy is 1,000 COD points. But if you have 900 COD points left in your account, you can never use them. You have to add the COD points, which you can't do in increments of 100. You can only do it in increments of 1,000. So you will always have a leftover stack of things in an account where you actually paid for. And using in-game currency or blockchain, you can actually get rid of these leftovers or use them in other games to pay for things you want to buy in those games. And then there's the question of interoperability. There's a lot of games that are very popular and that are sequenced. I think there's now like 12 different type of Call of Duty games. But the things you've earned in the first game of Call of Duty are not applicable anymore in later games of Call of Duty. And that is when you look at Call of Duty, which actually is made by the same company. If you see people that have been gaming for 20 or 30 years, those people have earned so many things in these games that that can't be used in other games. So there's a limitation of interoperability within games now, and using blockchain, these limits can be conquered. Well, some future possibilities for in-game items. There's of course the possibility of creating provable unique items. People can actually go to a blockchain like Ethereum, find the smart contract, and see the exact circumstances or the exact logic in which a token is created. And you can also validate if a token is unique, if a hash is unique. Then there's the possibility of cross-game interpretation of items in currency. This is something I thought of when looking into this. It will actually be possible to earn an item in one game and then use it in another game. One of the requirements for that is actually that gaming companies, developers work together or actually use the same token standard. So we are still a long way away from that, but it's a fun possibility that's out there. Well, we already touched upon this one too. Items are more easily tradable when they're on a blockchain or when it's blockchain items, and they can be interpreted by a trading platform using token standards, and therefore making it far easier to trade items than going through all the hoops that you have to do now. And lastly, using a wallet which only you have access to makes you a genuine owner of items. Right now the case is often that your account is still owned by a company or a gaming company, and if they think that you are cheating or they don't support the game anymore and go offline, they can shut down the game or shut down your account, and then you no longer have access to the items you have bought with your own money. Using blockchain, this can be solved. Items are no longer limited to being used only inside a game, but can also be taken out of the game, and which also makes it easier to be a true owner of your in-game items. Well, that was it that I wanted to say about using in-game items on a blockchain, and I'm actually looking forward to the possibility that this brings for the future and different applications in games. So, any questions?
Okay, thank you for your presentation, Menno. Looking into the comments to see if there are any questions right now. Not at this moment, so I might have a question for you, Menno. You talked to us about coin leftovers, and you mentioned a lot of benefits for the players themselves. So my question actually is, what is the incentive for game developers? Like, I mean, if you have these coin leftovers, I mean, that's profit for the developers, right? So what's in it for them?
Well, there's actually a few benefits for the developers. I think the biggest one is marketing. If blockchain gets more and more popular, or blockchain is already pretty popular among gamers, because gamers spend their whole life on the internet, and they have already read about Bitcoin or blockchain. Gamers can, or game developers can actually catch the interest of these gamers by offering them opportunities or possibilities to get in-game items. And at first, it won't be of great benefit to the players or the developers, but it will be just a marketing effect. But as this development grows and more applications start to use this, then this could become a necessity to have items that you can take out of the game. And then secondly, there's also the creative freedom, or the possibilities for items being used in one game as well as in another, or creating virtual trophy rooms for things you have earned in certain games. These creative ideas can give certain developers an edge to develop more interesting and more innovative games.
Okay, I imagine it can become a very big market, new market. Do you know if there's any numbers out there about the market right now, or?
Well, I think right now the gaming branch is, or gaming market is totaled about 150 billion. So that's billion with a B. But I think only 50 billion of this is licensing. So getting access to games, buying physical copies. But 100 billion of this market is actually in-game items, is these silly hammers you use in Candy Crush to smash your way to victory, or any other in-game item. So already the in-game item has outgrown the licensing market.
Okay, interesting. Okay. Menno, thank you for your presentation. No more questions from me or the audience. So yeah, I would like to thank Menno and Derin for their presentations, and of course our audience for their attention. If you like this Build Tech Talk, please like and subscribe. Also make sure to check out our YouTube channel for other tech-related presentations. Yeah, that's it, everybody. I would like to wish you a great evening. Thank you.
you.